This is the first example in section 2.6 day 2. We're going back to asymptotes a little bit, and then later on today we're going to talk about all the different characteristics of rational functions. But slant asymptotes come up when we're talking about the top-heavy version, or the top-heavy case of rational functions. Ones where the numerator, the degree of the numerator is larger than the degree of the denominator, specifically when it's 1 degree larger than the bottom. So what we've said before is that it just doesn't have a horizontal asymptote, but now we're going to actually replace it with something and have something concrete that we can use for the asymptote, and that is called a slant asymptote. So slant asymptote, if we graph it, that might be a good idea just to see what it looks like first of all. So I'm going to put that into my y equals. You'll see that I've got the parentheses in the top and the bottom. That's important to make sure that your calculator is doing the right thing. I'm going to graph this. This is going to be in zoom standard form, and you'll notice that along here it looks like it's kind of following a path. That's going to be a slant asymptote. We could put a straight line in there. We could draw a straight line in there that would, these two ends of the graph would get really, really close to that line without actually touching it. Exactly the same as like a vertical or horizontal asymptote. It's just that it's slanted in this case. Now, in order to do that, we're going to find the slant asymptote, we're going to use long division to divide. Now this, again, I say long division just because that covers every case, but since we have x minus 1 as the divisor, since we're dividing by a linear factor, we can just use synthetic division. So I'm going to do that here to save a little bit of time, a little bit of headache. I'm going to set this up as synthetic division. I'm going to put the dividend in the middle. So 2, -4, 1, and then the divisor is x minus 1, so that means our k value is 1 on the outside. Bring the 2 down, multiply by 1, that makes it 2 over here, add those, so it gives us -2, then 1 times -2 is -2, add those together, and we get -1. Now one thing you also may have seen in this list is step 2 to ignore the remainder. The remainder in this case is, the reason we can ignore it is because as you go out to the right forever or to the left forever, the remainder isn't going to have much effect on it. It's going to be basically canceled out when we go out there. So what we're going to do is we can just cross out that remainder, ignore it for the time being, or for the whole problem actually. Now what this represents is, well, if this is a remainder, this is the constant, this is the x, and so now we are talking about y equals 2x minus 2. That's going to be our slant asymptote. It's just divide and ignore the remainder. Now step 3 I do have on here is superimpose the function in the slant asymptote. I think it's a good idea to do that. I'm going to put that on my calculator. So the slant asymptote is, as we have found, 2x minus 2. I'm going to put that on there with the graph, and we should notice, oops, wrong graph. Oops, I put it on that instead. That's not going to do a whole lot of good. 2x minus 2. There's our graph. Now the slant asymptote, if you can see, is kind of going right through the middle there, and it looks like it's almost the same line. If we trace this out, you'll notice that they're getting really, really close. Maybe we even zoom in on part of it. And we zoom in out here, see how close they're getting. Looks like they're getting really close. As long as it looks like they're really approaching each other, then we can be reasonably assured that we have the correct slant asymptote. Now, if this were changed slightly, you'd probably notice it quite a bit. Let's say that we made this, I don't know, 2x minus 2.5, just to point out the difference here. If I put that one on there and I went to zoom standard, it's going to be a lot more obvious that that's not the correct thing. You'll notice that it's skinnier up here, it's more of a gap over here. That's not going to work very well. I could also just maybe like change the slope ever so slightly. Maybe I change the slope to 2.5, and I look at the graph, and clearly that's going off in a different direction. So superimposing it, just putting it on the same grid, can really help you to know if it looks like it's the right thing.